Welcome, everyone. Welcome to our fantastic show. You have now entered the cosmic radio receptors on KCIW 100.7 FM, located just a few tiny miles north of the California border in lovely, coastal, sunny Brookings, Oregon. Thank you for tuning into this week's interesting program. I'm Dr. Gigi, and my co-host is, as always, Jacques Kepner. How are you today, Jackie Poo?
Greetings, everyone, and welcome to the Doc and Jacques Radio Variety Show. Special thanks to Tony Stoddard for manning the flight deck of the enterprising starship of KCIW, as he has been doing for many months now. Thanks to legendary KCIW founder and finishing sound engineer, who among other things, puts this whole show out for syndication, Tom Bozak I'm talking about. Hello to you. And Linda Bozak, thanks for your support and help. Lastly, here on special request is Michael Gorse. Michael is the man that has that videographer's eye of a seasoned film director and lends his talents in a myriad of wonderful ways here at KCIW. Thanks to all of you. That's right, a big thanks. Also, right, Doctor, did you see that? I wanted you to give that. You say that.
I'm the green dot?
Yeah, you're the green dot.
Okay. Thank you all for listening to our fun and cute and quirky show. But a special thanks to John Bradford.
Hey, John, what's going
Karen
on?
Vogl
Hey,
and
Karen.
Jaden. You guys rock, and thank you for always listening. Thank you.
Right on. You're hearing this live syndicated show right now on KCIW's in Brookings, Oregon. That said, the same syndicated show will be rebroadcast in exactly 1 week from today, each and every Wednesday at 8 a.m. on our coastal southern friends, KZZH 96.7 FM in Eureka, Humboldt, Arcata area. And then at 1 p.m. on KFUG 101.1 FM in coastal Crescent Beach, California. It used to be called Crescent City. So now you know, Dr. Gigi and I have your coast covered. Okay, it's that time when good medicine and health tips are colorfully presented by my German-American multi-patent holding medical doctor, scientist, university professor, syndicated broadcaster, newspaper columnist, and did I mention artist? And so much more. Dr. Gudrun Gigi Reed. Okay, Doc, what medical marvels do you have for us today on this week's health segment of MDGG?
Well, stop some more.
Stop some more.
Telling all about me.
Yeah, those nice things. I said, it's all true.
Today we're going to talk about rashes.
Rashes?
As in, we have shingles and the poison ivy rash that some people actually mix up. So I have patients coming in and think they have poison ivy rash, and it turns out they have shingles or vice versa.
Wow.
So both can leave a person miserable, and they're not the same.
They're not the same problem at all, right? They're totally separate.
They're not.
Doctor, I'm not lazy, but I just follow Newton's first law of motion, which says a body at rest wants to stay at rest.
Okay. Let's go to shingles. Shingles is caused by the reactivation of the varicella zoster virus. That's the virus that causes chickenpox when we're echolums, but we can also be adults for that matter. After a person has had the chickenpox, the virus can remain dormant in the nerve roots for years and years and years, and can later flare up as shingles.
Shingles, yeah. Doc, I have a hen who can count her own eggs. Yep, she's a mathema chicken.
Now, if you all remember my article or my radio presentation last time or the time before when we talked about allergies and such, poison ivy rash is actually a contact dermatitis, a hypersensitivity allergic reaction. It's an inflammatory skin reaction caused by, for example, poison ivy, poison oak, poison sumac, chemical irritant, or another allergen.
Hey, if you had to choose just one body part that had the ability to smell, Doctor, would you pick your nose? So sorry. This is how the show goes, Doctor.
So the one I'm talking about the difference now, one of the clearest difference of these two rashes is how the rashes feel. Not how they feel if they're timid or if they're boisterous, how they feel to the person. Shingles usually announces itself with pain, burning, tingling, or tenderness along somewhere in the skin before the rash is actually coming fully out. Some people have I've never had it, but some people describe it as a hypersensitive, since the skin being hypersensitive, where even clothing or light touch can hurt.
Yeah, I've heard it's horribly painful, right? And isn't it part of herpes? Is it the same herpes virus? Or
It's their DNA viruses.
Really?
Yeah, they're in the same larger group. Yeah.
And how often do you see people with shingles? Is it on the rise?
Actually, I have seen lots of last year or the year before, maybe even during the COVID, because shingles comes out in stress
Right.
situations like the herpes virus.
Can it be transferred from one person to the other? I mean, is it contagious?
Well, shingles is not contagious, but it can cause chicken pox in people.
Wow,
Yeah,
that's
when
right.
it comes out.
Doctor, what is the absolutely worst thing that you can do after a funeral?
Pray tell.
Wake up.
Mm-hmm.
Could you imagine that? Okay.
Contact dermatitis is different. It's more defined by an itch. It can sting or burn too, but the skin is very irritated, especially also from the itching that you're doing, from the scratching. The intense itch is the hallmark, and with shingles, it's really not the itching, but they just visually look very similar.
And it's what?
And it's, what do you mean?
Inflamed. I mean, it's super red, right? Is that what I'm...
Yes,
Okay.
you're right.
Okay.
you.
So, hey, I went to Bora Bora. I want to go to Bora Bora, doctor. I'm just too Bora. I keep telling myself I should stop drinking, but I'm not going to listen to some drunk who talks to himself.
Okay, the rash pattern can also help distinguish the two. Now, shingles typically appears in one side of the body, and it allows a band-like or stripe-like pattern along a nerve pathway. And so that's when you go to the doctor and they say, look, this looks funny, then, or providers. The providers know what a nerve band-like pattern looks like, where the nerves go along the skin, and that's really the reason how they say, oh, this is shingles and this is not shingles. You might have little clusters of fluid-filled blisters along the line on the body. Usually it's going across the body. You want it, but only part way. You don't want to have it in your face. That can be long-lasting and can have sequelae or lasting bad things happening if you have it there. Now, if you have a little patch or a streak, or you work on your garden and all of a sudden you have all these blisters on your hands, there are itchy, then that's poison ivy.
That's poison ivy, right? Hey, I have no problems with genetically modified food. In fact, last night we had a scrumptious leg of salmon.
The course of the illness differs as well. Shingles often lasts 2 to 4 weeks. That's like the standard. But when the rash is only but the rash goes away, it can actually linger for a long time, and then you have pain. As a matter of fact, I worked with somebody who had shingles, and she said after the rash was gone, it was the worst pain she's ever had. And she bore a child. So, wow, it must be pretty bad.
Today I entered everything that I ate recently into a new fitness app. The first thing it did was send an ambulance to my house.
Okay, back to the pain. Can last months or longer. That's called the post-herpetic syndrome. Contact dermatitis, usually, you have it, you wash it off. If it's an oily substance, you have to wash it out, not with water, but with soap or something, oil, detergent, soluble detergent, and then it goes away. So that one is a much faster approach to cleaning up the rash.
Hey, Dr. Joe, there's a nudist convention in town next week. You should go if you've got nothing going on. Okay, I finally got him to laugh. He smiled. What do we do?
Okay, treatment follows the course. Shingles is often treated with shingles, that's the virus one, with antiviral medications, especially if it gets caught within the first 2 to 3 days, you get the antiviral medication. And then you often get also nerve pain medications, gabapentin or such. And the goal is not that you don't get it, but it's shortened and you can't spread the chickenpox virus so easily.
Interesting. Keep going. You could finish.
Contact dermatitis is treated by washing off the irritant, but often it's just treated with steroids, cold compresses, calamine lotion. And so just on the rash. You don't have to, if you have it all over the body. I've had a patient who was a young boy who just rolled in the grass, not knowing that much of the grass was poison ivy. So he had to get shots and Benadryl IV and everything. He was horrible. But then it goes away after a couple of days. So that was my story.
Okay. Now, shingles always appears just on one side of your body, right? I mean,
pretty much, unless it's disseminated, meaning it's all over the body. But pretty much it's on one side of the body.
Okay. There we go. Well, thank you, Dr. Gigi, for enlightening us about rashes and shingles. Two things I wish not to have.
Well, shingles have rashes. A rash is just kind of something on the skin. So it is the poison ivy rash versus the shingle rash.
Okay. All right. Thank you, Doctor. On today's edition of Doc and Jacques, we have the distinct pleasure of welcoming someone who embodies both a lifetime of scientific curiosity and a deep love for the art of cinematic storytelling, our new Brookings neighbor and friend, Dr. Joe Vogl. At 91 years young, Joe brings with him a remarkable past as a retired astrophysicist, having spent decades exploring the mysteries of the universe. His career was devoted to understanding the vast mechanics of space, stars, galaxies, and the forces that shape them, contributing to a field that continually reshapes how humanity sees its place in these cosmos. While Dr. Joe may speak fluently the language of science and his work with amazing clarity and wit, he has spent his lifetime curiously observing, analyzing, and discovering at the highest level of scientific inquiry. But what also makes Dr. Joe so fascinating is how the same sense of wonder has genetically passed on into another passion of his, cinema. Today, Dr. Vogl is an avid film enthusiast with a stunning private screening room that rivals many state-of-the-art movie theaters. Perched in his lovely Brookings home, this meticulously sound-engineered theater space is more than a luxury. It is a personal temple to storytelling through film. For it is there that Joe continues his exploration of the universe in a different form through the lenses of directors and writers and all those other wonderful people. I forgot to turn off my phone.
Oh, my gosh.
Okay. That had to happen. It had to happen one time in 3 years, right? First time. Through the lens of directors, writers, actors, and cinematographers who, like scientists, seek to interpret reality and imagination alike. So, alongside his talented artistic wife, Karen, Joe has quickly become a cherished part of our Brookings community. Their generosity and kindness remind us that a life well lived is one that continues to evolve, lives that bridge science, art, and human connections. Everyone in the studio is honored to share some time with Dr. Joe Vogl, and we invite you into a conversation that promises to be as expansive as the stars and yet poignantly compressed into the perfectly framed movie scene. Without any more verbiage from me, Dr. Gigi Reed and Jacques Kepner, welcome Dr. Joe Vogl to the Doc and Jacques Show. Welcome.
Welcome.
Well, thank you for inviting me. It's my pleasure to be here. I've never had such a bunch of accolades to my past in my life.
Oh, I'm sure.
Embarrassed by.
I'm sure you have. And I apologize. So I forgot to tell you, my one rule is turn off your phone.
You told us.
You didn't have any phone. He doesn't have a phone. He didn't really believe in him. Well, you do, but
all right, Joe, I'll ask the beginning questions. When and where were you born and raised?
Well, I was actually born in Brooklyn, New York, and started in Flatbush, and then my father was in the Navy, so we moved around a lot in the East Coast. He taught signaling in the Navy, and so we went to different naval installations.
Signaling like with the flags up and down and left and right?
With signal flags. You remember him practicing in the living room with my mother made the flags on her sewing machine, and my father was in the living room snapping these things around. It's amazing how fast he could whip those flags around. They made big snapping sounds as he flapped them around.
Right.
Very cool.
You were now born pre-war, right? You were born in
Which war do you
Second World War. Pardon me. Second World War.
Yeah, that's right. Yes, that's right.
And so you were a kid during the war.
Yeah, that's right. I grew up watching our forces, actually, or listening to them on the radio and reading about the newspaper as the war progressed in Asia and in Europe, yes.
Right on.
What brought you to this area? here in Southern Oregon,
Well,
coastal?
when I first came to California to go to graduate school, we drove around the coast and up visited different places. And I remember driving to Carmel and going on a 17-mile drive. And I said, this would be just wonderful to live on the ocean where I could watch the waves crash on the rocks. And so when we got to retirement, we started driving up the coast and trying to find a place to buy. And California was way too expensive. So we kept going north and north and went as far as Florence and then started our way down. And it turns out that we knew somebody, as it turns out, in Brookings. When we got here, called them on the telephone, they invited us over, and we said, this is the place. And there are lots of rocks and water, and you can afford a place on the ocean. And so,
Right. And when was this? In 20 years ago? 25 years?
this was around 2000, 2001.
Cool. So
Yeah.
good 25 years. Cool.
Very cool.
Go ahead, Doc.
Why did science interest you? When did it start? How did it start?
Well, it was an odd coincidence. As you pointed out, I was brought up during World War II, and I was fascinated by the planes and tanks and boats that were being used. And I remember going to the library, and here was a book called The War Against the Germans. And I was fascinated. Oh, this is going to be great. So I brought this book home, and when I got home and opened it up, it turned out I misread the title. It was The War Against Germs. So I had the book and I brought it home. So I said, well, I got it. I might as well open it up anyway and take a look. And so I got fascinated by that. And it started out with the invention of the microscope by Leuwenhoek in Holland, and just started talking about all the scientific discoveries that followed from that. And that got my interest really peaked in science. I said, wow,
What
this is
a
really
great
great stuff.
story. So that you ended up getting involved with, more interested in germs than the Germans.
That's
and,
right.
and the Germans have Germany, many of them.
Yes, that's
Germs,
right.
many, right? Oh.
Yeah, they have them too.
All right. Where did you do your undergraduate studies?
I went to Columbia University in New York City. I lived in New York City. That's where we ended up in the final place. My parents, after my father retired from the Navy, and in New York City. And so I went to and applied and got into Columbia. I got a fellowship to go to Columbia, so I was able to afford.
Were you a real city person? Did you go out a lot? Did you go eat at diners and?
Well, I used to drive a Coca-Cola truck all around New York City, and in particular Brooklyn and
Really?
Queens. Yeah. So when I was in school, I made my money by driving a Coke truck as a Coke salesman.
Huh? How fun.
Yeah. They tried to convince me to drop out of school and become a permanent Coke salesman. No, I don't think so.
Yeah.
As a career, that's right.
So when did you decide you want to go for a PhD? When and where did that happen?
Well, first, the way I became interested in, I shouldn't say, I was always interested in physics and astronomy in particular, and then, but I wasn't sure what I was going to do when I went to college. And as we were graduating from high school, we all get our yearbooks, and I was running up and down the halls with my yearbook trying to get people to sign it. And here comes Mr. Weissman, who was the head of the physics department at Brooklyn Technical High School. And we get into a conversation talking about who's doing what. And his favorite student was a guy named Martin Feldman. And I said, well, what's Feldman doing? And he had this downcast look and said, well, Feldman's going to go to Rensselaer and become an engineer. I said, engineer? Really, Feldman? And he could tell he was down. So we talked about that for a little while. He says, by the way, Joe, what are you going to do? I said, oh, I'm going to study physics, of course, sir. What else would I do? You know? And he smiled and got a big smile on his face. And then
He signed it to the best student ever.
the best. And then at graduation, I was the valedictorian, so I was up on the stage, and Mr. Weissman gets up and he says, well, the gold medal in physics goes to Joe Vogl. So now I felt that I was committed to studying physics. Okay?
You could have said, no, I want to just be an engineer
I could.
like Feldman or whatever.
I really wanted to be an astronomer, but I thought the hours were so poor. You know, I have to work all night long and sleep in the daytime. Then I decided, and I loved physics, so I put the two of them together.
Astronomer, you're up all night long. Have to sleep during the day. Now, after Columbia, then you were accepted, and you went where?
To Caltech.
To Caltech?
To Caltech, that's right.
And is that where you got your PhD?
That's where I went and got my PhD. I spent 5 years at Caltech and studied with, there was a big astronomy department. Caltech runs Palomar and Mount Wilson, so there's always been a big interest in the radio telescopes in the Owens Valley. So Caltech is a really big astronomical center.
So we looked up your thesis and we asked AI to dumb it down like 3 times in a row, and it still didn't make any sense. So I think I want to ask you, tell us about the Oppenheimer movie and seeing part of your thesis stuff in there. What happened?
Well, I was noticing my thesis was based on protons, the interactions that take place in the center of the sun to produce the sun's energy. And there's something called quantum tunneling, in which a particle can actually go through has a probability of going through a wall. And they had a drawing of that on the boards in the background in the Oppenheimer movie. And I was looking at the equations that went with it, and the equations were not the appropriate equations for quantum tunneling.
Some janitor just got a parent scribble on the board, right?
That's right.
That's something. You didn't know that your formula was on there. You just watched the movie and saw it.
Yeah,
right?
that's right. I watched.
How
That is
very, very interesting. Now,
hasn't happened to me yet.
And I was also a little annoyed when they made this big deal about the atmosphere exploding because of chain reactions, and there was a concern about that Edward Teller brought up. And Edward Teller is really into nuclear fusion. That's what he was all about, the father of the hydrogen bomb. So he was looking at fusion of the atmosphere. And they never showed what the actual the equations were that would, like the nitrogen fusing with other nitrogen, or nitrogen and fusing with oxygen to produce like silicon-28. That's what the reactions were, but they never showed that. They had these complicated equations that really had nothing to do with the actions that they were talking about, okay? So they were passing on to make it appear to the audience that these guys are really studying something really deep. They had equations that really didn't fit the situation at all.
wow. Well,
Very cool. We asked you the other day, is your research still used or whatever, however we worded it? And then you said, well, that's not the kind of research. You found facts, right? This is how
That's right. We measured the reaction rates for 2 of the reactions that take place where the sun produces this energy that we get every day. And the reaction rates, measuring those reaction rates, the cross-sections for the reaction rates are physical numbers that never change. I mean, that's the way carbon absorbs hydrogen atoms and protons, and that's never going to change. And so I measured those reactions in the labs, and that's the end of it.
So it's still viable today, what you were learning?
Yeah, well, there was a little controversy about that. I don't know if I mentioned that to you, that because of my calculations, you can calculate the reaction rates in the center of the sun, and there are a lot of neutrinos produced by these reactions.
They go through everything, right?
Neutrinos we have billions of neutrinos going through our body every second.
Wow.
And when they're produced in the center of the sun, they don't even be absorbed in the sun. They can go through the whole sun without being absorbed. So it's very hard to make detectors but people have made detectors with down in very deep mines. And they measured the neutrino flux from the sun, and they discovered that the neutrino flux of the sun was less than it was predicted to be. And the people being a competition between MIT and Caltech, the people at MIT said, oh, this can all be explained. It's just Vogl did his thesis wrong. If Vogel's thesis was wrong, that would explain why we're getting a lower number. So then the people of Caltech, of course, they're not going to take this lying down. So they went back 25 years later and measured the stuff that I measured in my thesis and discovered that, well and behold, my thesis was correct. There were no errors in my thesis. So then theoreticians went back and looked at the theory of the neutrino and discovered that the neutrino is a 2-component particle, and it goes through stages, and only 1/2 of those stages could be detected by the detectors that they built. So that's why the reaction rate was only 1/2 of what they expected it to be. So they
Very cool.
A new theory for the neutrino.
What is it? Vindicated? You're vindicated.
Vindicated. Okay, I got to pull this off the cuff question just to get it out and over. Who was the greater scientist? Was it Newton or do you feel Einstein? Which of those two?
Oh, I against down Newton.
Yeah, all right. Newton. Well, nothing against Germans, Dr. Gigi.
So you're an astrophysicist and you did all this astrophysics stuff. Oh, wait, we haven't even talked about the astrophysics, the part of the lunar stuff before we go. You actually spent most of your career not as an astrophysicist doing the astrophysics.
Yeah, where did you spend the majority of your career? We're doing what?
Studying the local space, designing satellite systems, and just there's a whole range of different kinds of satellites that I worked on and helped design and study. And
so military,
both NASA satellites and military satellites. I worked on both of those. Some from the earliest satellites that the U.S. put up to I retired.
So what are the sizes of those satellites?
We had
most people have not seen.
We had these little tiny satellites that were only a few inches on the side, and they were supposed to be really, really cheap. And for antennas, believe it or not, they cut off pieces of tape from measuring tape. And we got pictures of satellites with these measuring tapes sticking out, little octahedrons and dodecahedrons.
And so that was worth sending up in space?
They put those up into space. So that was the smallest satellites. And then one of the satellites I worked on was called OGO, the Orbiting Geophysical Observatory, and we called it a streetcar in the sky, because it was like 20 feet long and 6 feet on a side, and had booms on it that were 20, 25 feet long.
Wow.
And then the DSP satellite, which I worked on a lot, is a military satellite for detecting launches of ICBMs. That's about 20 feet high.
Intercontinental ballistic missiles?
Intercontinental ballistic missiles, that's right. And SLBMs as well, submarine-launched ballistic missiles.
Oh, boy.
So how do you get those things in the air at whatever, distance they're circling us? The satellites, how do you get them up there?
Well, you have launch vehicles with multi-stages on them.
It's like a plane that...
Well, no, you burn some kind of fuel, like... Most of the rockets we use today, the highest ISP, which is the energy that you can get out of a burning fuel, is liquid hydrogen and liquid oxygen. When you burn liquid hydrogen and liquid oxygen, it gets very hot. You get a lot of energy out of that. So in terms of the mass that you need, you can get the most velocity. Although people have sometimes used liquid fluorine and liquid hydrogen.
And then you disconnect them from the little launcher?
Well, you get separation, so the multi-stage rockets, and you have the biggest one. And because when you get up to a certain altitude, you want to get rid of the weight of the first rocket. When it's empty, you get rid of it, so you don't have to accelerate that. So now you've got a lighter weight rocket for the second stage. So when you watch it, you can see
they separate.
You can see the separation of the first stage separating the second stage, and then you have to have a rocket left. Like when I was working on satellites that go into geosynchronous orbit, you have to have a rocket left to put you into the geosynchronous orbit, which is a circular orbit at about 40,000.
What is the rocket equation? Quickly, what is that?
Well, that tells you how much. Well, you have to understand that you have so much fuel in a rocket, and at liftoff, you've got all the fuel there, and so you've got a maximum mass. The force is always the same. So as the rocket is being propelled, you're burning up fuel, and so it gets lighter and lighter, and so you end up with getting more and more acceleration, because force equals mass times acceleration. The mass is less, the force is the same, so acceleration keeps increasing. So the rocket equation tells you how much fuel you need to get to a final velocity. You have some kind of velocity that you need, say, to escape the Earth's gravitational field, and then you can determine by the weight of the rocket itself how much fuel that you need to be able to achieve.
Interesting. So you're shedding that fuel. It's getting lighter as it's going up?
It's getting lighter as it's going up. That's right.
All right. Time flies when we're having fun. It's already that mid-break time here on Doc and Jacques Live Radio Show. Proudly broadcasting from the KCIW 100.7 FM studios in lovely Brookings, Oregon. The list of major sponsors for this community radio station are Advanced Airlines, flying in and out of nearby Crescent City to Oakland and LA 7 days a week. Michelle Beaupert Michelle Ramos with our own vibrant local Curry County Chamber of Commerce, Nick and Lisa Rail in the PPA, or the Partnership for the Performing Arts. A new, fairly new reporter for the community radio is, what is it? Who do you work with, Doctor?
Hospice,
Coastal Home Health and Hospice Services, of which
and
you
I
are.
also work for the other.
Yeah, well,
owners,
okay.
So.
Lastly, my dear co-host, Dr. Gigi Reed, and yours truly, on behalf of KCIW, thanks to all of you. We're in the studio talking with Dr. Joe Vogl, who is, as I said earlier, not only our a very interesting man, a retired astrophysicist, amongst other things, and our neighbor right down the street, who we've become acquainted with and become good friends. Thanks a lot to Michael Gorse. Thank you for the introductions there and others. We appreciate it. So we talked about the rocket equation. It just gets lighter as it goes up because it's shedding fuel. And then once it goes out of the atmosphere...
That's when you're supposed to be done burning the fuel, right?
Well, you have to sometimes, like I said, if you're going into a Earth orbit, then you have to circularize the orbit. And the only way you can circularize the orbit is that you have to burn fuel when you get to the apogee, which is your high point in the orbit.
Yeah.
You get to the high point in the orbit, then you have to burn fuel to circularize it, or else it would be just an ellipse that would go back down to the Earth again. So
the other interesting thing that is some satellites have little fuels to go a little here, a little left, so they can right and left, so they can be where they're supposed to be, or they have their own, what's that called, when they spin on their own and then.
There are two basic kinds of. Well, there's three, I guess you could say. The one program, the Defense Support Program, was called a zero momentum spinner because it was
they spin.
It was a spinning satellite, but it had a reaction wheel inside that spun in the opposite direction, so that you could, because think of a top, how difficult it is to move a top when it's spinning in a different direction. So, but that's what keeps the satellite stable, so you don't have to use a lot of fuel to keep it oriented. And so that's one of the reasons for launching a spinning satellite, so it keep oriented itself. Otherwise, most satellites are 3-axis stabilized, and they have reaction wheels built inside that are continually moving to keep the satellite oriented in the direction that you need it to be. And eventually those wheels get up to the maximum speed that you can get them to, and then you have to fire fuel jets, to bring the speed down by firing the jets in the opposite direction. But you use up a lot of fuel that way, and that often is the limiting lifetime of the satellite, is how long you can.
I want to back it up a little bit and give a definition, let's say, of what is astrophysics. I asked you this, and what would you? Well, give me the.
Well, I would say the nice one: structure and evolution of celestial entities. Okay, so structure and evolution of celestial entities.
So that means.
And I use the word entities because it's hard to define a gas cloud or a plasma cloud, or even a whole galaxy as a body, or I don't know. So I just use the word entities to describe all these kinds of celestial.
But it's also the planets themselves, the stars.
The planets, the stars, and the gas clouds in between.
And I can't imagine how you can track all this, because everything's in a constant motion. Everything's spinning. Everything's going around one another or circling, and then you're just calculating. Wow.
Probably the universe isn't rotating. We don't see any rotation.
Really?
It's expanding, but there's no measure that it's actually wrote that there was any imparted angular momentum during the Big Bang.
What's your best guess of what was before the Big Bang? Just
no guess.
Ether. What was it called? Ether, not ether, but ether. Ether, yes. Wow.
Yeah, just a vacuum, the ether of the vacuum. Yeah.
Would you encourage others to go into astrophysics at this time?
Oh, now this is the time of really the golden age of astrophysics, because we're building these satellites that are able to do things that we could never do before, like the James Webb Space Telescope as their infrared telescope, and that's placed in something called Lagrangian point, which is far away. You have to have it far away from Earth so it doesn't get warmed by the Earth's radiation. and there are these stable. Something wrong?
Yeah. So,
There are stable points in
Yeah.
the sun Earth orbit that you can put that the James Webb Telescope is, and it's got to be cooled to a very, very low temperature, like a temperature of liquid helium, so that you can see out far into the infrared. And so it's always,
Why does it have to be far away from the Earth? I didn't.
because the Earth's radiation would warm it up. And so it's got it's got a big shield on it, so it doesn't get warmed by the sun. But then you can't put a shield and orient it the way you want and everything. If it was near the Earth.
So you put, I don't know, 50 gallons of liquid nitrogen, whatever you put up there.
Well,
How
liquid
long does
helium,
it-
yeah.
Or liquid helium. How long does it last?
Maybe 5 years.
Oh, whoa.
Yeah.
Okay, very cool.
so you think it's the golden age of this astrophysics? And it's
Well, because of that, and also the use of computers. When I was in school, computers didn't really exist, and so you can do a lot of, like, for instance, one of the calculations that nobody ever would have thought of, when you have two spiral galaxies colliding with each other, it turns out because of these huge supercomputers that run for days and days and days, where they calculate the orbits of each one of the stars in the two colliding galaxies, you end up with spiral galaxies becoming a big elliptical galaxy. And we've always wondered where did elliptical galaxies come from, and that's where they come from.
Wow.
And that was never known before. There's no way that you can predict that until you do these.
Tell us another prediction, dark matter or... Yeah, dark matter.
what
It's
is dark
based on predictions, right?
Well, it's not based on, no, it would be nice if it were based on prediction, but unfortunately we don't have any, like Einstein's equations for general relativity there's a idea that maybe they're slightly wrong because we measure gravitational forces that aren't there, that we can't figure out what the origin of them. If there were stars in our galaxy that are moving so fast that they should have left the galaxy, but yet they remain here, so there's more mass in the galaxy than we can see and measure in order to keep those stars here. And so that's dark mass or dark matter. And it's, unless the equations of general relativity are wrong, but people have looked at all the predictions of general relativity, and it's been verified in every single measurement that we've ever made. So we can't find anything wrong with that theory.
So there must be a way of detecting dark matter that we haven't found yet, right? So it's the wavelengths, or I don't know, grams. I don't know. There's another measuring tool that
Well, it might
we
be a
don't
kind
use,
of particle
right?
that we don't have any, that we've never seen before, that
Yeah.
we can't measure because it doesn't emit any electromagnetic radiation. It doesn't scatter light when it goes through. It's just
Right.
something that doesn't really react in any way except gravitationally. If it reacted in the electromagnetic spectrum, we would see it, you see, and it's not. So
But it can react a different
and
way.
it
that
doesn't
we
light
don't
up
have
from
measured.
sunlight or anything. That's why it's called dark matter, because you can't see it. Even when you go to this far infrared, where you can see very, very dim objects, that's the purpose of the... I've heard of the red shift, right? That the further out particles are, the redder they get. And that's one of the reasons for building infrared telescopes, so that we can see that stuff that's way out on the edge, because it's going to be very shifted into the red. And so we get to be able to see further and further out with telescopes that can see longer and longer wavelengths.
Yes, we talked a little bit about this last night, where we asked, is physics ever going to change? It's just the laws that exist now that you are a master of, the laws of physics. And you said something interesting. Oftentimes people experiment trying to explain, that law of physics doesn't work. They're always trying to disprove it, or scientists do try to prove it. And what would happen if they disproved one of the laws of science?
Well, people have spent, there was Dickey at Princeton spent most of his career trying to show that, for instance, the 1 over r squared law for electromagnetism isn't really 1 over r squared. It's, instead of being 1 over r to the second power, it's 2 plus a tiny number, and he got that number down to 1 part in 10 to the 18th by doing all kinds of measurements to see if he could find, because if he found any error in that at all, he immediately get a Nobel Prize.
That's right.
And that's why people are so interested in trying to find errors in these laws that have been around for
Right, and that's so much
decades.
easier. You can disprove by one thing. If you're successful, you can disprove something by just one experiment.
That's
but
right.
Proving, you can never prove something because you can just give more evidence.
You
that
can
it
give
is
more
right,
evidence.
Right.
Well, what happens is that you come up with a theory, and this theory predicts certain things that you've never measured before. And so then you go out and see, is this really the way the universe is? And then you find out the theory predicted such and such. Like, well, I'll give you examples of, I think I mentioned to you before, the advance of the perihelion of Mercury, that for hundreds of years people have seen that the Mercury orbit precesses around the sun with an unknown cause. And when Einstein developed his theory of general relativity, there was 60 arc seconds per century, which is like 1 minute of arc per 100 years, which is a very tiny amount, but it was still unaccounted for by all the actions of the planets and the sun and so forth.
Wow.
And when you do a calculation using general relativity, lo and behold, you come up with that 60 arc seconds. And so that was a big validation right off for the theory of general relativity. And then there are precision of tops and a bunch of other experiments that are very, very difficult to do because they require great accuracy. But every single time we do any of those experiments, we always say, yep, the law of general relativity is correct. We've never found any experiment that we've ever done which said this is not what general relativity predicts. So we believe, but then we do have, like I've said, this dark matter and dark energy that we don't know where and what that is. We just postulate it because we see reactions that don't follow the law of general relativity.
But you have to have tools to measure these things. So is mathematics one of the tools that you...
Well, sure, mathematics is a basis for all of science. I mean, it's...
Yeah.
Tell us about the moon mission that you were involved in. What did you do? No, not as an astronaut, but the math or the physics behind it.
One of the things I was doing, we had an experiment that we were going to fly on a surveyor mission to measure the lunar ionosphere. The lunar ionosphere is basically the solar wind hitting the moon, and then it gets absorbed by the moon and then emitted. And so we had an instrument that was mass spectrometer that was going to go in and measure the components of the lunar ionosphere, which was really the components of the sun, and to see whether our theory of what the different isotope in the sun were correct. So we were going to but unfortunately, because what always happens is not always, but often, that people underestimate how much something is going to weigh. And so the objects that have to be flown end up weighing a little more than you thought. And so they have to start scrubbing the satellite. And one of the things they did was take off our experiment. So we never got to fly that mass spectrometer, but we got pretty close. We built one and we had it approved and everything. And then at the last minute, they said, sorry, guys, we don't have the mass available to do this.
Wow.
But then I worked... Bob Sackheim, who was the head of the propulsion department, the company that I worked, our company developed the lunar excursion module, the descent engine, the LMD, and that was the engine that saved the astronauts on Apollo 13. On Apollo 13, the main module had an explosion in the oxygen tank and had to crawl into the lunar excursion module and go right. They, of course, never landed on the moon, and they used the excursion. The engine in the excursion module to get the astronauts back around the moon and get us back to
real
Earth.
life.
And then Bob Sackheim came up with a neat idea of having a big 2-page ad in Aviation Week that said the last 350,000 miles are on us. Aww. And they had a picture of our lunar descent engine, which was never designed to do that, but and it's amazing at those without the use of computers and so on that they were able to figure out when to fire it, what angle to turn the spacecraft in to fire it.
What is a couple of non-swearing words that you would say to people that say, oh, that was all faked? All the moon it was all fake. Never happened. The shadows were all wrong. There was wind.
It's one of the things I point out to people is that here it is, like 50 or 60 years later, and we all remember the exact same. What's the chances if these were lies that everybody would remember the same lie?
Yeah.
Repeat the same lie. This many years later, it's hard to remember the details of lies, but when you live through it,
Yeah.
you remember what you lived through.
Right.
And so everybody has the same story, so half a million people were involved in this program. And there was a huge amount of paperwork generated. One of the things we used to say is that if we could never get to the moon with a rocket, we had enough paper generated in the program that we could climb to the moon on the paper stack.
Okay, let's switch to movies.
Movies, cinema? You mean cinema, art?
Cinema, yeah.
Wow, you are fascinating what you did. I got to back up one last thing.
Sure.
You were involved with getting the lunar lander back up into space. And was that using propulsion? I mean, and no gravity?
Well, it's the same as a rocket taking off from Earth. I mean, we had a lunar excursion module, the LEM-D. It was lunar excursion module descent engine, and it fired to lower the two astronauts onto the surface. And then had to be enough. On the very first launch, I didn't realize this, read this recently, that the very first landing, they had a hard time finding a flat place on the moon, and they kept moving around, and they almost used up all the fuel.
Wow.
It wouldn't have been
almost
enough
used up.
fuel to get back into orbit when they, because they have to have enough fuel to lift off again.
Yeah.
Had to dispose of a few things here and there to make sure that the weight was not over too much, so they could, because they had to get back up to the
And that was one of your babies.
yeah, that's
right?
that's what we did, was to build that calculate how much fuel was needed and measure the specific impulse of the engines. And we measured all these things in the laboratory to make sure that they were in. All these things always have to undergo the rigors of space. So we have these chambers that test the environmental conditions of space, the ultraviolet light and zero gravity and vacuum chambers.
Wow.
And so
That's pretty amazing. I mean, you're one of many people who worked on it, right? One person not doing their job, one person sleeping on the job. I mean, that all could have been scratched. I mean, if you have just a little bit too little fuel for that to come back, I mean, it's just amazing. Just
Ground
Can you imagine
control,
leaving one person
major
behind
ground.
who's going to stay behind?
Yeah.
Something.
Yeah, right. I'm going to have to get beyond. Well, thank you for going back on that. And I think if I were to call you out and say that that was all faked, I think you'd show me your door and tell me to leave your home.
okay, let's just move on.
Get out.
Yeah, that's right.
Back
You
to cinema,
are-
doctor. Joe,
I always wonder what people get out of that. Why are they so intrigued by claiming that these things didn't happen? I just...
All right, so do you have a lunar movie that you like especially?
A lunar movie.
Yeah, like what was that one?
Bear
Space
Mountain?
Cowboys? No.
Space. Wait, not Midnight Cowboy.
No,
No, well,
Space Cowboys
there
is
were some of these
actually-
movies about,
Mars.
incoming asteroids that are going to destroy the
Oh,
Earth.
yeah.
Yeah, those are kind of interesting. To how early do you have to get to an asteroid to change its orbit enough so it's not going to impact the orbit? But blowing one up doesn't really solve the problem because
You have an absolutely incredible studio set up for that. How many movies do you have stored up there that you know of?
well, I keep a list in Excel, so I have them all alphabetized, and I just looked at that list.
A couple hundred, 340.
4,730.
Wait a minute, 4,730.
Yeah.
And is that,
And we have watched 1,000.
no.
And some of them, that understand. Some of them, one title would be all of Star Trek.
Yeah, I
Next
was going to say.
Generation.
You mean all the episodes, or you should count each one of those episodes, right? They're all an hour.
Well, then,
45 minutes.
then
you have.
you
only
I
count
have
one?
I have a lot of series like The Sopranos. Okay, that's one title, and there were a whole bunch of things for The Sopranos, and a lot of the British TV shows that were long playing. So those are all just one, like Inspector Morse. I don't know if you ever heard of Inspector Morse. So I have Inspector Morse, and that's again just one title. But then sometimes you could have duplicates because of like 3 or 4 different copies of The Fifth Element, because The Fifth Element came out first as a DVD, and then it kept getting improved, and so every time it came out, it was improved up to the latest version, which is a 4K. So I have like 4 copies of Fifth Element, and they're all different. So I have So in a way, it's cheating to say that's 4 titles for one movie there.
Okay. Now, we also asked you some questions. We said, what's your favorite? It's not easy nor fair to say what's your favorite movies, but per genre, let's go down a list. Let's say, do you have a favorite Western movie? Just off the top of your head, any favorite movies rise to the top? Hang 'em High.
Silverado.
Tony's saying Silverado is one of your... Yeah?
Silverado. High Noon.
High Noon is one of my favorites. Yeah, that's a really cool movie. Because I read a lot about how that was made, and so I have a little personal.
How about musical? Yeah, several favorite.
Well, I really like operas a lot, and there's always this confusion between musicals and operas. But, for instance, an opera that I really like is Evita by Andrew Lloyd Webber. That's one of my favorites. Okay, and then classical operas are Don Giovanni. And when I went to college, we considered that to be like the greatest opera ever written, Don Giovanni by Mozart, and he's my favorite composer.
So we got to watch that. How about, were you carrying a switchblade in the 60s after West Side Story came out? Remember, sales of switchblades went off the roof. Everybody's buying one.
Well, one of the odd things about West Side Story, I was told, is that when he's running down the street yelling Maria, that only one window opens.
Very interesting, very astute.
And then you like the Chinese and the
we have lots of foreign films.
Yeah.
Yes, it's Gong Li is a really great Chinese actress. She's like our Elizabeth Taylor or somebody like that, just so famous in so many great movies.
Right. We watched Hero the other night, right? That was...
Hero was
and we watched Raise the Red
Lantern. That was...
Raise the Red Lantern was another.
Curse of the Wild Curse of the Yellow Chrysanthemums with Leah. There's a lot of movies. The Shanghai Triad is another great.
Oh, yeah. I've heard the Shanghai, maybe from you. How about one of your favorite movies with Tom Hanks? Do you have a favorite?
Well, we talked about the movie Greyhound, which is the most intense movie I've ever seen. It's not exactly a real story, but it's close to a real story of what it would be like to be the captain of a destroyer escorting a convoy from the United States over to England at the beginning of World War II with the German submarines,
the U-boats,
the wolf packs that would be attacked. Yeah. There was 6, 8, 10 U-boats just waiting for this convoy to come, and we'd see it. And this is all in the movie. He's got to make these constant decisions, and they're literally life and death decisions. So I pick these guys up in the water, or do I go protect this other ship? And it's just a incredible decision making that he has to, and he's going to do this every time. It's not just one mission. He's going to keep doing these missions over and over and over again. It's amazing that somebody can stand, and this movie really brings.
How about what would you pick between some of the oldies, African Queen and the other one with African Queen, Casablanca,
Casablanca or Maltese Falcon? Those
those
are all. One of the things I like about those old movies is they have such great lines in them that you can remember for a long time. There's like one of the movies is All About Eve with my favorite actress Bette Davis, and she's talking to her agent, and she says, "You're a man of no do you have any principles?" He says, "I'm a man of very few principles, and all of them are open to revision."
Now, Jacques said before how old you were, which is rude, but anyway.
91 years young. That's okay.
And what is your secret? So nobody would guess your age, and
No.
certainly not when they hear you and how you talk and such things. So what is your secret to a long life?
Well, I've been told that for every hour that you spend running, you add an extra hour to your life, and I've run like 35,000 miles in my life, which is a lot of hours. But then other people point out that extra hour that you gained, you spent running.
See, there's the scientist. There's the scientist and Dr. Joe here. Yeah, he figures those things out. You used to run how many miles per week consistently for years?
140 miles a week. I ran average of 20 miles a day. I once ran in marathon on Saturday and another marathon on Sunday.
Holy
I actually
smokes.
set the course record on the Sunday.
Oh, my
For, I was over 40, so I set the course record for over 40
Whoa.
on
Wow.
Sunday. So I used to,
Scary.
but if you run 20 miles a day, it's almost like running a marathon every day anyway.
Yeah.
You're an active guy, and that's why I think, and you're very social. You integrate with everybody. You talk to everybody. You're very, very affable, very informed, and really a good guy. So I think that your social interactions is helping you a lot. Yeah, it helps you a lot. Where do you see yourself in a couple of years from now?
Hopefully still walking my dog on the beach.
Yep.
Climbing up the hill from Mill Beach to my house.
I think that's still right.
Yes.
I did it twice today. And I give a shout out to Kiko. Hey, Kiko, what's going on?
Yeah, shout out to
Kiko, come here. Have another treat. Oh my God, he's
It's amazing how many people in town, oh, look, here's Kiko and his owner.
Yeah, we noticed one of the first nights as your neighbor, we noticed you walking the dog. Literally, you were walking the dog. You were holding him, and
Yeah,
you were
Sure.
walking.
Yeah.
I thought that was funny. Gigi, what's the last question we're going to have for our guest?
I don't have any more
Yeah, I
because
do.
we have.
What do you? What is your tombstone going to say, Joe? We asked this to many, many people on our show. Do you have any quick ones? Just that you
that's
made it
tough.
and you figured it out.
That's a tough one. Yeah, I've thought of other people's tombstones that are pretty clever, but
Okay. I wouldn't have one right off the tip of my tongue, anyways. All
All right.
Okay,
Well-
Dr. Joe Vogl, thank you for coming
Thank you for
in.
coming in.
For
Super
enlightening
interesting.
us. We will have you
Yes.
back in 6 months to continue our exploration.
Maybe more into cinematic.
Yeah, let's go more.
Maybe
into-
we have a grip on the thesis then, and I can explain it in layman's.
And by the way, you could look up Dr. Joe Vogl, Vogl,
Mm-hmm.
right? On Perplexity, look it up. It spilled out your whole thesis. So it's
Yeah.
out there.
But-
I would have a copy of it on my shelf. All you need is to come by and take a look.
Why bother with AI? All right. Thank you so very, very much again. We're honored to have you on the show. Doctor, do you
so
have any
much for
great...
having me.
All right. Do you have any...
We have, what do we have now?
Oh, fun time corner. We have just a minute, so...
All right, half a minute.
What do
I
we got?
have great quotes.
Yeah, but...
The universe is under no obligation to make sense to you.
Okay, the universe is under no obligation.
Absolutely.
I like that. That's very good.
Absolutely.
Yeah.
Okay, keep going.
Astrophysics teaches us that we are not the center of the world.
Nice.
The cosmos is all that is or was or ever will be. That's Carl Sagan.
Right.
Oh, stay gone.
Saigon. A screwdriver walks into a bar and the bartender says, "Hey, we have a drink named after you." The screwdriver looks surprised and says, "You mean you have a drink named Philip?" I thought that was cute.
That was very cute, but I really laughed
Hey,
beforehand.
when
You know
Victor...
who invented the Phillips screwdriver?
Who?
Philip Wrigley.
Wrigley there.
One of the
Wrigley.
Wrigley family. Yeah.
The gum people. Cool. And the baseball field. Any more last
And the
quote?
Wrigley baseball field. That's right.
Extraordinary claims require extraordinary evidence.
Oh, what was the one you say about the murder of great ideas?
The great tragedies of science are the murder of beautiful theories by ugly facts.
Theories of ugly facts. Is that not a classic one? Wow.
Very cool. That was
right.
so fun, but we are done. You guys, you have been listening to the Doc and Jacques radio show on KCIW 100.7 FM in Brookings, Oregon. We sure hope you enjoyed our show as much as we have learning about our new friend, Dr. Joe Vogl, and astrophysics.
Yeah, indeed. Peace and prosperity to everyone out there. And again, thanks Tom Bozak and Linda and Michael Gorse. Thanks for filming it. And Tony Stoddard in the desk, in the booth. Thank you so much. Please have a great, great day.
Goodbye.
Bye.